Okay, let's have a look at compound interest or compound decay as well. You can get both of them. So this is where, like, you start with a number and it keeps either increasing by a certain percentage each year or decreasing by a certain percentage each year. And there's literally really one thing. If you understand, this whole thing becomes very easy. And by the way, these are usually 3-4 markers as well, so they're big. And yeah, you should expect them to come up as well. They really always kind of come up in the calculate papers anyway. So here's the deal. It's like there's a guy, Toby, and he starts with £4,500. And it goes, you get 4% compound interest. Now here's how it actually works. So at the end of year one, here's what you got to think. If we find 4%, yeah, you grab a calculator. Do this with me, by the way. You can find out it's 180. Okay, and then you could, I guess, so that means at the end of year one, you could add 180 onto that. So it's got 4,680 at the end of year one. Now, after the second year, you don't add an extra 180 because think about it. Initially, they're saying to you, "Oh, we'll give you 4%," but you're like, "Okay, you gave me 4% when I had $4.5 grand." Well, hold on, I've got more. I want more than £180. So what you have to do for each year, unless, I'll show you a trick how to get through this quicker, is you would literally have to find a brand new 4% of 4,680. So if you do that, the answer this time it would be £187.20p. You'd add that on, so now you've got 4,867.20p. Which is fine. I mean, it's doable, but it's time consuming. And here's something else. Imagine if I asked you, okay, how much money does he have after 8 years? Yeah? Well, now we've got a real pain in our ass. Yeah? This is going to take forever. So I want to kind of show you like a quicker way of doing this. So let me just kind of get rid of a lot of this kind of stuff, okay? Come on. Let's rub it out. Ignore my kind of like, Actually, there you go. Okay? Here's a little trick you need to know. So we want to know how can we, instead of having to, what we're doing right now is we're sort of doing find 4%, add it to original. That's what we're doing. Now there's a way which we can do it much quicker than that. Okay. Now think of it like this. Okay. So imagine 100% is what you start off with. That's what you always got to start off with. Can you see right now what we're doing is we're adding 4%, we're finding 4%, and then we're adding it on. So what we end up with is 104%. That's how you increase by 4%. Does that make sense? Now, fractions, decimals, and percentages. 104%, yeah? Are you happy that's the same as saying 1.04? As in that's how you'd write decimal as percentage. What we can do is if we take if we kind of go back to this start 4,500, instead of finding 4% and then adding it onto this original, try do this, multiply it by 1.04. See what happens. You'll get the exact same answer. Year 1, 4,680. Now multiply that by 1.04 again. And straight 4,680, and you can skip that extra line of working completely. Okay? Now here's what's so useful. Imagine if this was can you see what you're doing is you start with 4,500, and then if you want to increase by 4%, you times by 1.04, and if you want to do it for 2 years, you could just basically be doing times 1.04 times 1.04, which is, you could actually do it much quicker by doing 1.04 squared. So we could have found it out immediately like that. Does that make sense? I mean, I know I'm kind of doing it reasonably quickish, but so here's the deal. If this question was like 8, it said, oh, he does it for 8 years. What you'd be kind of doing is you kind of like start with 4,500, but if you want to go straight to year 1, you can just sort of times by 1.04, and then get to second year, you do 1.04 again. This will get you to 2 to 3, and so on. So can you see essentially what you're doing is you're taking 4,500 and you're increasing it by 4%, that's 1.04, do it to the power 8. If you put that straight in that calculator, you would know right away that we've just done it for 8 years. It is as lovely as that, assuming it kind of clicks, of course. If it doesn't, that's what the lessons are for. But let's have a look at a few more questions and hopefully you should kind of get the gist of it. Okay, and I do also actually, what we need to actually kind of look at as well is when it decreases. So say you've got something like this. Okay, so this one is where it, well, let me actually first do a question which is kind of the same. Okay, so we'll come back to when it decreases. It's almost the same, to be honest. Oh, damn it. Okay, so it invests in 2 years, okay? So I'm just going to draw this for the sake of like giving you what's happening, but we're going to be using a much quicker way. We're going to be using the quick way. And see, why don't you pause it and try to see if you can find the quick way. So can you see what you're trying to do is you're trying to kind of add, you're trying to find 5%, then you get a new number 5%, 5%. You're trying to do this for 3 years. Okay? Now, how do you should be asking, how can I add 5%? That's when you do 1.05. So literally to get to the first year, you can just do 1.05. Okay? And then you can do 1.05 again and 1.05 again. So the quick way of doing this is take your starting value, you times it by 1.05 to the power of 3. That's you adding 5% for 3 years. Put it in and it literally is as quick as that, and your answer should be 2315.25. Okay, simple as that. Okay, now similarly, okay, let's look at, this is obviously compound interest is when you always add money on. I mean, you wouldn't put money in a bank where they're going to take money from you, so that's always going to be adding. Okay, let's have a look at this. Okay, so here's the deal with this one. So you've got a car into, you know, work at the end. Okay, we don't forget this one because we don't want to start here. Let's kind of do this. Okay, so there's a car is bought for, say it's bought for 12,000. Okay, so someone goes buys a car for 10,000. It says it depreciates in value by 8% each year. How much is it worth? I don't know. After 4 years. Okay? Now, obviously, so it's like you kind of start at 12 grand. So we kind of see how much would it be at year 1, year 2, year 3, and finally year 4. Now, obviously, if it was increasing by 8%, we would do times 1.88, because think about it, we start with 100%, we find 8%, and we add it. Yeah, so that's why we get the 108%, and then we can just turn that into decimal. The only thing that is different here is we still want to find 8%, but we then want to minus it. So if we start with 100%, which we want the value, and we want to take 8% away, we're left with 92%, which as a decimal is 0.92. So what you want to be doing to actually remove 8% is you want to be timesing by 0.92. And then each and every year, just to take away that, you just keep doing that. Does that make sense? That's how you get rid of it. So you can literally do it by 12,000 times 0.92 to the power of 4. And that's you removing 8% each and every year. So if you do that 0.92 to the power of 4, yeah, you got 8596.72. Remember, with money, you always go round it to 2 decimal figures. But does that make sense? Yeah? So that's all it is. I mean, you just got to decide, okay, am I going up or down? And what would the kind of new decimal be? So if we kind of go, Let's have a look at this. And we can have a look at a few different. Here's a good one. Oh, it's virtually the same as what I did. But happy to pick 12 grand as well. But you get the gist. Okay? So here's the deal. Here's how we do this. Okay? So we start with 12 grand. And it's going to depreciate by 25%. So think about this. We start with 100%. We want to find 25%, and we want to minus it. What percentage will we be left with? We're left with 75%. Our decimal is 0.75. So we want 12,000 times 0.75. We know that will kind of like remove 25% each year. We want to do it for 3 years, so we just literally do that. And you get 3 or 4 marks from this once you understand this, from literally just writing that and just shoving it in your calculator. So the answer is 5062.50. Okay. Now let's just look at a few different variety of different types of question, so we can just kind of feel comfy on how the different kind of questions could be asked. Here's a good one. Okay, so we got Henry over here, who's investing 4,500 things. So here's the deal which we have. Okay, this one's different. So you sort of start with 4,500, and like we don't know how many years this one has been done. So it's like Henry invests 4.5 grand at a interest rate of 5%. So can you see, because it's increasing, we want 1.05. So literally to go to each year, we'll be doing 1.05, 1.05, and it goes after a certain number of years. It just happens to be there's some mystery year where it just happens to be 5469.78. Okay, that's basically what happens. So really, and it's the same. Okay, we'll find the value of n. Well, this is difficult. Well, at first glance. So we're like, because we don't know the power. So imagine that's like n. That's your mystery number. But we do know when that happens, we get 5469.78. So what do? We literally just guess. Okay. So let's just pick like a random number. Let's pick like 10. So say if we did 4,500 times 1.85 to the 10. And I literally just pick it at random. Okay, the value I've got is 733003. Whoa, that's too high. So it's definitely less than 10. So I don't know. Shall we go to? Let's go to 5. And notice I'm not overthinking like what number I pick. I'm just like, okay, I just know that's too high, so I'll just come back and just change one of the numbers. Okay, if I do 5 now, I get 5743.27. So that's good, but it's still too high. So I want to go a little lower, but that's actually pretty close to that. Maybe I go to like 4, or I could have gone to 3. If I go to 4. Okay, yeah, and I got the one which I'm looking for. There you go. Okay, so the value of n equals 4. So that's the other way. You can actually also do guesswork, and there is literally just, it's as easy as that. You may kind of think, oh, but don't I need to know like a specific way of finding? No, you just guess. It's not going to be hard. You just pick a number. If it's too high, just bring it down. If it's too low, bring it up. And I don't actually recommend. Nah, forget it. Yeah, I mean that's simple enough. There's no need for me to overcomplicate it. Here's an interesting one. We'll just have a quick look at that. Pretty nice and straightforward, to be honest. Okay, so here it goes. So this one's just kind of wants you to have more of an understanding of what's going on in terms of kind of their working out. So it goes, okay, he invests £500, on January 1st, 2004. It goes at a compound interest of R%. The value of the investment of n years. Here's the formula if you want to find out the value. So now have a look at that. So what they've done is 500 times 1.045 to some sort of power, which they've called n. So they're saying find the value of R. So R is what percentage compound interest is there. Now notice it's 1.045. Now if you did that as a percentage, that's 104.5%, right? Because you just times it by 100. So can you see the compound interest here is 4.5%. So the answer here is 4.5. That's literally all they're going to. For you to see that meant 4.5% is being added on. So for example, let's say if it was 1.12, that would be 12%. If it was, what would it be if it was 1.7? Well, you've got to remind you that's 1.70, 70%. That's the logic which is working here. And it goes, use Bill's calculate to find the address map after 20 years. Well, this isn't rocket science. Just put in 1.45 to the 20. Does that make sense? Okay, so that's that. I'll also go new. No. There's a good one which I wanted. Yeah, let's have a look at that. That's quite a good question, because I can imagine the wording kind of bothering people here. Okay, so it goes, Gwen has bought a new car. All right, and each year the value of the car is depreciated by 9%. So can you see, like, that would mean it ends up being 91%. So we're going to be using 0.91 here. It goes, calculate the number of years after which the value of her car was 47% of the original. So notice it didn't actually give you a value. So here's what I'm going to do. I'm just going to basically give it a number. So when it's new, I'm going to say it cost 10 grand. And then basically 47% of it is 4,700. And you can just, you know, that. So it's like, when did it go from that? So I could say, okay, here's what I'm going for. So like, imagine it's 10,000. I know it's decreasing by 9%. So I've got to find out what this n is, where it finally gives me 4,700. Okay, well, let me guess. Let me start with 10. You know, there's nothing special about 10. But so can you see this is the guess game again? Okay, that's giving me 3894.16. So I don't want to kind of decrease. I've gone too far. So now let's just back up a bit. My gut tells me 8, so I just go with it. It doesn't really matter. And yes, it looks like I found it. So that's roughly about that as well. Yeah, so it's not exactly bang on, but it's 8 years, which I want. Let's check 7. Yeah, happy with that. So it's not exact bang on, but it gives you the right answer. There's a really good one. Oh yeah, this one. Okay, so this one's just like slightly different, and I'm even going to make the question tougher, so just so we have something like that. Okay, so this one's only asking for 2 years, the question, but I want to imagine, say, if like the question would ask 4 years. Okay, 4 years. So here's the deal. There's this bank which gives you 4% for the first year and then 1% each year after, and there's another bank which will give you 5% for the first year and 0.5% each year after. And it goes, you know, there's Viv, who obviously wants to have the most money after 4 years, so which bank should she invest 2 grand in? So let's have a look at this. If I kind of think, so if I start with 2,000 here, so if I go year 1, year 2, year 3, year 4, let's think about this. So, you know, let's kind of find our decimals. So if you want to increase by 4%, can you see this would be 1.04, this would be 1.01, this would be 1.05, and this one would be 1.005. So for this one, you would actually have to times by 1.04, then you'd have to be times by 0.1 times 1.01. Ignore what I say, what I write is actually correct. Okay, so you could literally just get the calculator out and do 2,000 times 1.04 times 1.01 to the 3, and there's no quicker way of doing that, but it's not very long either. Hopefully that makes sense as well. So you can just basically, at the end of this year, in this bank she's going to get 2143.03. If we do something similar here, it would just be that this would be 5 and this would be 0.05 each time. Quite messy stuff which I'm doing. So for this bank, if I want to find out how much I get, 1.05 times Okay, put that in, and for this one I get 213166. So yeah, this is the best bank for her to do. Okay, so it's just what this is just as long as you understand it, you're not going to get caught up. All right, and I'll leave it there.